Hi everyone, my name is Ali. I'm a VP of AI product at Sandbox. Today I'm with Stefan and Timo. So today we are going to talk about LQMs. Maybe Stefan, since you have been here for a long time and I know you are an expert on LQMs, define what is an LQM and like how is that maybe different from LLMs?
Yeah, well, I mean, it's a great question. So the LQMs, it stands for large quantitative model, right? As opposed to large language model. And I think for me, the starting point for LQMs is not so much a what is an LQM, but why is an LQM, right? And this gets to the difference between an LQM and an LLM. And really, I think there are, let's say, two pillars or two foundational ideas that lead one to the idea of an LQM. One is the thing that I think everybody has been noticing over the past few years is that LLMs by themselves, these language models, they can't do everything, right? They're really good at a lot of stuff, surprisingly good at a lot of stuff, but they are not universal machines to solve every kind of problem. And in particular, a lot of the problems that we care about at Sandbox, more quantitative problems that are not based in language, but based on, say, the behavior of the real world or other kinds of quantitative data, not fundamentally based in language. A pure language-based approach is not necessarily the best approach. So one popular approach is, well, if the language model by itself can't do a thing, let's give it a tool. Let's give it a tool that can do that thing. And so there's a whole industry now of giving language models tools to let it extend its capabilities. And so that brings you to like what ends up being an LQM. An LQM, I would say, is not just a single kind of model or a single kind of architecture, right? It's more of a design pattern, right? It's a design pattern that leads you towards solving this variety of problems. But taking all of those modules and different kinds of services together, connecting them end to end, mixing and matching them like Lego bricks, and tuning the whole thing so that it can really solve some of these challenging problems that we face, that is what I would call an LQM.
So I can actually build on what Stefan has said about the general nature and the modules for different modalities in the context of cybersecurity. So what's our fundamental mission? It's to secure the systems of our clients. And what are these systems, right? They are code, there are sensors in their networks, sensors that look at the files, and all sorts of, kind of log style, information that we have coming into our system. Some of this data is text for sure, and LLMs totally make sense to understand and make sense out of this data. But a lot of this data is actually numeric. So we might have, numerical models on things like traffic. We might have the LLM for, textual representations. We might have graph neural networks to model the topology of the network or something like this. So there's a lot of other ways how to model this kind of information and derive new type of information about it. Plus, you can always then go one level higher and put a layer on top of all these individual models that understand the individual parts and reason about it as a whole. And going back to what Stefan has said, that is what I would call the LQM then. And it can just reason about this broader spectrum, and this allows us to derive like much broader threat scenarios about a system than we could ever do in isolation.
Awesome. I think we are going to talk about some other use cases as well. But Stefan, I want to come back to you and I understand LQM as a design pattern, as you said, right? But in practice, how do you design it? What are the key components of technical components of the system? Can you talk about those for LQM?
Yeah, so I think it makes sense to look at some kind of particular, maybe not a super specific example, but say a category of examples. And one category of examples that's near and dear to our heart is in computational chemistry problems. So things related to the early phases of drug discovery or materials design or catalyst design and things like that. So in these kinds of fields, there are two kinds of approaches. There's these principled physics-based approaches where you're solving equations. So if I have a configuration of molecules, it can compute, say, the time evolution of these molecules. What happens to them? How do they jiggle around? Things like that, based on equations in ways that we understand. So there's several software packages like that. There are also AI-based approaches to analyzing similar kinds of problems, where solving the equation directly, it's too computationally intensive and it won't work. And so what do those look like? Well, those tend to look like things like, well, neural networks, right? Where you have, say, a configuration of molecules, but instead of looking at the positions and velocities and solving equations, what you do is you take that information about what the molecule looks like, pass it through some kind of embedding layer into some kind of latent space. There's some more neural network magic that happens in that latent space, and then out pops the answer for whether the molecule is stable or not, or what the stable configuration would be. And one thing that you may encounter if you're at the cutting edge of what's possible is that, say, the pure AI solution that uses these neural networks doesn't actually work. And so what you do to solve this issue of being on this kind of edge of what's known, this edge of where the data is reliable, is you set up an LQM that chains together this somewhat more computationally intensive, slower, but more reliable, more generally reliable equation solving piece, use it to create a set of data, then use that data to train or fine-tune the AI data-driven piece, and then repeat the process in order to eventually get to what you want. So these kinds of data flywheels are a hallmark of an LQM system, at least in these scenarios, and it becomes kind of a bit of a discovery engine, kind of pushing you in new directions where you didn't really know what was going on before.
Timo, does this also resonate in your space? Like maybe you can talk about the type of data, for example, you have, or the type of like modules that you do some sort of computation on top.
Yeah, absolutely. So if you look at different areas of cybersecurity, then you will always hear from customers the same problem. Data is, or the insights you're giving me, they are noisy. There's way too many insights about my system here, way too many potential vulnerabilities. So then the question just becomes, well, what is the useful context you can add here to make more informed decisions? Let's say you have a vulnerability that flows through your code. Let's say SQL injection. For those who are not in cybersecurity, SQL injection is you basically get a user input, you pass it into a database query, unfiltered, unsanitized, and then it does some damage there because it was manipulated in some way. The common thing to do is you have a sanitizer in the middle in the code somewhere that cleans this up. Knowing this context turns an issue into a non-issue. You know there is a sanitizer. The same way, knowing that this endpoint is never exposed. Let's say it's a test endpoint. Let's say it's on a system and a host that never gets any traffic, is also super useful to know, right? So in this case, there's let's call it neutral context that actually helps us by going one level higher to prioritize this gigantic list of inventory of issues down to something manageable and actually something you can decide on. There's other types of context. For example, customer context. You can simply build a feedback loop that either directly lets users decide what they're interested in and what they're not interested in. And for LLMs, that's simple, thumbs up, thumbs down on every answer. But there's variations of that in every sort of industry or every scenario, right? We can do thumbs up, thumbs down on the issues we show to users, but we can also just measure, let people vote with their feet, essentially, and see which issues they actually look at, which ones they ignore, how they just interact with our whole product in the end, and then measure indirectly and get feedback this way. So 100% agree, context is key, and there's a lot of things we can do on top of our normals that we built and in the toolbox really that make the overall product that we built this in better.
Got it. Awesome. Stefan, one question for you on LLMs. So there are a lot of advanced capabilities that are exist right now for LLMs, right? How do you see those capabilities in the context of LQMs? Like, do we also have like reasoning, maybe a different type of reasoning? Do we have agentic capabilities? Yeah, how do you see those?
Yeah, it's a very interesting question. Agentic capabilities are starting to take off, and there's still a lot of work to do. They're not 100% reliable. If you let an LLM agent run for a long time without checking in on it, it'll probably get sidetracked, hallucinate something, and get lost. But if we look toward the future, like where are we going? Something like an agentic LQM is the future of LQMs, where all of these different ingredients, all of these different services, they would be united under an agent that knows how to intelligently use them, make decisions about them, and be able to leverage them, as well as the experts that put them together, the domain experts that put them together.
I think that makes a lot of sense. And I can even see a step further in the future where the core of the agent is not an LLM but an LQM.
We'll know that we're in a new phase, a new future, when the lines between which part of the system is the LLM part, which part's the LQM part, when we can't tell anymore, right? When it's all kind of mixed together.
What are the type of challenges that either of you guys have in like using or like developing LQMs?
Yeah. Well, maybe I'll start. So the progress, the amazing progress we've seen on the LLM side came from and has come from stepping back and taking a general point of view. Like, I now have a system, this foundation model system, that can solve a lot of problems all at once, right? And as I was mentioning at the beginning of our conversation, one of the origins, part of the origin story of LQMs is recognizing the gaps, right? But those gaps are, they're isolated from each other. At what point does there, or at what point will there, or at what point should there emerge from these investigations something that can be a little bit more generalized, right? I think what should happen is, even if you focus on critical use cases at first, maybe mastery of those critical use cases should lead to, or I suspect they will lead to, the development of a whole, an expanding island of use cases that can be handled by a single LQM system. And we recover some of that generality that the LLMs have. And then maybe over time there's a percolation and we get we end up again with a unified picture. Right now it seems like it's too much, it's too much to expect, or too much to try to get an LQM that can address all the huge variety of problems all at once with a single model. But that's something that, I don't know, I've got my eye on, and I would like that to come true, but I think that's a big challenge, and it's not so clear how that challenge is going to end up being solved or resolved.
How about you, Timo?
Yeah, so if you look at how LLMs became that good that quickly in a way, right? Like, apart from the whole, popular consumer demand, that just popped up, and sort of like the possibility of it. On the technical side, you have, the factor that, transformer architecture just helped, digesting data and attention mechanism, and like suddenly there was a means. But on the other hand, no model is any good without good data, right? And we, for language, we just have an enormous corpus of data readily available, the internet, or books, or like humans like just produce this data incidentally by talking or writing or whatever. So we just had it. Without the internet, no LLMs. Very obvious. On the LQM side, we need good physical data or good measurable data, and it just is not that obviously available. So we need to go actively out there and collect it, and that's much more tedious, obviously, right? Like, there's lots of data preparation, there's lots of maybe synthetic data because the volume is just not there, so you need to augment it somewhere. But in the end, it doesn't change that it's there on a huge scale of brilliant to random, and you need the random parts too, right? So I would say, hands down, getting the right data to solve your to use case and to have something to learn from is the biggest challenge, probably.
Yeah, and I think what I've seen and what I really like about Sandbox is that bunch of different ways of like generating data, because like the data is a problem, right? So if you have a bunch of sensors across the teams, or like some of the simulations, or like running some of the libraries, scientific modules, I think that's a way for us to generate some of the data. But I agree, like the data is the key element and one of the pain points. So my last question, I am wearing my like PM hat, product manager hat. What have you seen already on the impact of these LQMs, right? So maybe Timo, I start from you on the cybersecurity side. Not only the existing impact and some of the use cases that you have, maybe talk about those, but also like what are the future possibilities of using LQMs in cybersecurity?
Yes. So, like I said, at the moment we're working, or everybody's working, really more on point-to-point solutions to secure one particular silo. So I think that the future is going one level higher and ingesting the whole variety of sensors that are there, and building like these comprehensive threat scenarios. Let's say you have a popular use case because it came up in a big breach 2 weeks ago, I think, when you have a tool that can manage your database. Now, by itself, that might look good. You add identity to the problem, then you get into like, okay, certain actors should be allowed to do certain things, right? The DB admin should be able to wipe the whole database if they decide so. That's all by design. So you need a bit of more context to reason what's actually safe. Then you go one level higher and put, let's say, the kind of reasoning on top of actions that are in general allowed, or that should be allowed, or that should be allowed in combination. And then suddenly you have a scenario where you let an agent loose on your database with whatever identity you gave them, and it wipes your entire company database. That actually happened last week or 2 weeks ago. And then you have a threat scenario that goes all the way through the stack, and you can say, no, this should not be allowed. The DB admin should be allowed, right? So you need all these layers to make those assumptions, and you actually need all these like layers to create a holistic threat scenario. And it's not only top down. There's new vulnerabilities where we found that by manipulating prompts of one agent, one tool in the agent, you can actually poison the other tools and in the agent, and there's all these like network effects basically. And what I'm saying is that without the whole picture, you can't make this. You can't even reason about it. So use LQMs to look at the holistic part and make these assumptions, or like confirm your assumptions or not, or reason about it. That's going to have huge impact on how the world works and how we secure it.
Yeah, I think, well, I'll stick to the through line that I've been using throughout the conversation of these kinds of chemistry-based examples like drug discovery and materials and catalysts and so on. And I think there are two signs of progress that I think we can see start to happen, and that we can look forward to coming online in the near future. One comes back to this discussion of data, right? So at Sandbox, we recently released this SARE data set for in the protein domain, and also this AQCat data set in the catalyst domain. And there's going to be more and more of that, which will have secondary effects on a lot of areas. But I think one other more concrete use case to focus on is specifically within drug discovery. The ultimate arbiter of success is the clinical trial, right? And if you think about all the ingredients that go in to making a successful clinical trial, it's hugely complex. It's not only, at the level of proteins and protein folding and molecular motions and stuff, but also at the level of biology, right? Like, how do these things actually create cascading effects that will hopefully cure a disease but not cause a side effect, and so on. And we like to base everything that we do, especially with LQMs, on first principles. But the first principles of biology are, they're several steps removed from the actual effects at the end of the day, and that would be a very hard equation to try and solve, right?
Awesome. Thanks for sharing those examples, and thanks for taking the time to talk to me. I think this was super useful, hopefully fun for you guys, and I think we should do more often. Thank you.
Thank you.
Thanks.
All right, thanks for watching, and please subscribe to SandboxAQ YouTube channel. Thanks.